My friends, welcome to this week's weekend special. This week we will be working on model Mania 2017. So this is a model developed by SolidWorks. It's their property and I'm just practicing on it today. So this model comes in two phases. First phase, it has these two indentation or depressions in this circular base plate. In phase 2, that 3 depressions takes place instead of 2. So that's the only change. Everything else remains the same, and I think I can do this switch with one click. So let's go ahead and start working on this first phase. I obviously want to use this in my advantage during sketching. So this is diameter 65. Let's make this half transparent and keep that on XY plane because this is the diagram that I will be using. And let's see if we need to change the center of the image to the center of the workspace. There. Now it's all ready. First of all, I want to build this circular base plate, and I want to do that on XZ plane, and that's a 65 millimeter diameter with 3 millimeter thickness. So let's go ahead and draw a sketch on XZ plane. That's the side because I'll be revolving it, and I want to build it like this. Because there is a center hole, I'm just keeping a gap in there and then build something like a reverse L or something. So this is the thickness, and let's make that horizontal, not vertical, and the thickness is 3 millimeter. Okay, the overall height of the base plate is 15, and then overall diameter of the base plate is 65. So it's going to be 65 divided by 2, and then the gap in the center is diameter 16. So we have our center hole embedded in our sketch, and now let's go ahead and revolve it against the axis so it's default, and let's go ahead and hit OK. So this is what we have. My idea is to build one of these units, embed it into this using the connect tool object, and then replicate that 2 times. So let's see if we can do that. So what I want to do, I want to build this one depression in there. I don't want to attach it with anything. I want to do it on XY plane, and the offset, it would be on top of that. So it would be 15 millimeter offset, which is the height of this wall. And here I'll start with, so I'm gonna take the outer side, right? Oops. Okay, I'll have to fix a few points of this. So first of all, I don't want this perpendicular constraint in there, and I want to place this center at the center, and now I want to make these two coincident, and this is radius 32.5 for diameter 65, and this point is going to be on here, which is the diameter 44, so it's going to be 22, and the angle between these two is given as 45, right? and maybe we want to make these two on the same horizontal plane. That's one way to make it symmetric, and now the entire thing is symmetric. Okay, so we have 1 degree of freedom left, I think, which is the radius of this. I don't think it's given, and I don't know what else to actually constrain it with, so I'm gonna go ahead and make an assumption of a radius of 11, maybe 11.5. okay, all right. And this center hole, I'll be cutting them later on using an array tool. Okay, so we have the revolve. On top of that we have this part, and I want to extrude that downward for 3 millimeter, which is the thickness of it. So I want to reverse it, and there it is. Okay, we got that. Now what I want to do, I want to hide this on this face, or even on this. So this is, I would say, unit thickness. Okay, within that I want to reuse that sketch, so copy that and paste it, make it visible. I want to build that wall, that 3 millimeter wall. Now see here, the wall doesn't actually, the old wall does not continue on that part, so I will only use, I want to take this one and make it a construction geometry, right? And then take rest of the 3 actually, so I'll select them one by one, and then take this thickness offset geometry. Okay, I'll have to delete some of these. So that's a 3 millimeter offset, and let's go ahead and delete these outside edges. Okay, we want to delete those and make up this gap with 2 arcs. Okay, so that's one, and that's another. Now that gap is going to be a 3 millimeter. All right, and this is going to be 3 millimeter as well. And then, so if it is 11.5, this radius is going to be 11.5 minus 3, because that's what the thickness is. And I think there is something wrong. This 3 is actually taking as the degrees. We don't want that. I want to take this point and this point, right, and take a dimension of 3 millimeter. Okay, so that's a big difference, the 3 millimeter and 3 degrees. We take these 2 points and take a dimension of 3, or we could make these 2 parallel. Anyway, so we still have 2 degrees of freedom left, and which is one of the centers. Make those coincident, and that should take care of it. All right, so we got this wall. So this is unit wall, and it will obviously go down by, I'm just gonna take a wild guess and say 15 millimeter. Okay, and obviously it's going to be reversed. There we have these 2, and let's see how it plays out with this revolve. And I think it plays out good. So I want to make these to 1 unit, right? So there it is, 1 unit, and I'm going to say depression unit. Okay, and now bring the revolve back. Let's see if connect tool does its magic and make a good connection here. So take these 2 and come here and say connect object, Oh, it did. Pretty cool. That's all we wanted. We have this, right? But we don't want to do this right now. I want to do it after I array it 2 times. So here's number of elements is 2, and reset point and hit OK. So we get 2 of them, and now see if the connect object connects. It did. That's all we wanted. That is all we wanted. So only thing left in phase 1 is these 4 cylindrical holes, which we can do easily, right? So we take a cylinder, and the diameter is diameter 7. So let's update the diameter as 7, and height, let's make it 50, right? And then I want to move it upward to, I think the diameter was 22 right here. Yes. So I want to take this cylinder and the placement in the position on Y, and say make it 22. Now I want to take this cylinder and array it 4 times, but this 4 comes as 2 times 2. That 2 is actually a number of elements from the previous array. For now, let's go ahead and make it 4 and make it like that, right? Maybe I want to take this cylinder and notch down, so this is a -5. Yes, no reason, just wanted to make it visible on both sides. All right, so final task would be making a deduction just like that. So that's our phase 1, but I want to go back. So say phase 1 no fillet. I want to go back in there and say this is named as array. Click on that and find that 2, right? Here it says count. So the name is count under array. And here I want to come here in the array. I want to make a formula, right? So here, let's see if we can find that. So write array, first one, and then say count. Yes, there it is. We found count. So times 2. And what it does is, now these 4 holes are related to these 2 repeating original units. And before I apply the fillet, I want to do a trial. I want to go into array and change this. So I cannot change this count. It comes from number of polar units. So I'm going to come here and say make it 3. Look at that. So what it does is, now it's repeating 3 times with 3 times total 6 cylindrical holes in there. And actually that's phase 2. So that is phase 2. Phase 2 has 3 depressions with 6 cylinders holes. And there's, I think I missed one thing though. All right, so we are in a good path. Let's bring it back to 2. So at this stage, I saved the same file as phase 1 and phase 2, and I kept phase 1 open. And here, all I have to do is take this line and then make it a fillet. Okay. And come here, fillet, and I think it's 2 millimeter fillets all around. Yes, so make it 2. Let's make sure like we have all 4 edges selected. We have 2, yes, 4 edges selected. So we have 4 edges, made them 2 millimeter. I think at the same time we could take these 2 as well. Right, so I'm gonna come here into the fillet, double click on it, say this line, and make it 2, and then pick this line and make that 2. Okay, all right, halfway there. And now on the second fillet, I want to take this, and that line should come around and make another 2 millimeters of fillet. Pretty cool. So that is our phase 1. Phase 1 done. Let's open up the phase 2 we just saved during the progression of phase 1. I think this is it. And here I'm gonna go ahead and actually edit the name and then change the array to 3, and this takes us somewhere. Now let's go ahead and import that image. Right off the bat, I can see that there is something changing in the middle. So we are not there yet, but we're pretty close. So there will be a cylindrical shaft kind of thing, and this drawing says only this side will change. The other side will remain what it was. So this one on the far side would remain same. Only change will happen on this side. I think the easiest thing would be to actually fill that gap up by another extrude. But if I had to build only phase 2 to begin with, I probably would not do what I'm about to do. But since we are transitioning from phase 1 to phase 2, I want to keep my progress and do another sketch on XY plane and fill things up. So here I want to draw a center circle of 16 millimeter diameter, and then I want to take reference of these 3 edges and then hide that. So turn on section view and let's start drawing things. So I will go to center arc and kind of like take a couple of arcs. So this is going to be 22 diameter, 11 radius. All right. So now we have a 3 millimeter wall in here. Okay, I want to go ahead and make all of this coincident. Actually, that creates a thing. Oh, I see. There is an auto constraint applied. I don't need that. I'm going to delete that and take this center coincident here. Okay, so that was my bad. The FreeCAD 0.22 version adds some automatic constraints, and symmetry is one of the new ones, and I don't think it's doing a great job so far. Okay, now I want to make it a boundary. I'm gonna go ahead and make all these 3 equal so they have same radius, and now I want to make this solid geometry. So the easiest way, over the time I have experienced that things like this, I can go ahead and say this is tangential right now, but it would create more problems. I'm going to go ahead and make this like that and come back later on to fix them. So this constraining in arc to arc has been an issue so far in my experience. I don't know if it is a big deal, but so this is the most effective way. Come back to make them equal, and that won't give you any trouble. Okay, now take the line and connect these two. So do that 6 more times. All right, so we have this is the gap that we are filling up. I'm gonna go ahead and close it out. So that's the sketch, and I want to rename that as a sketch gap. Right, extrude that up by 15 millimeter, and that fills up everything. Now I can go ahead and make these two one fusion, and that is our phase 2. Well, of course without the fillet, but that's our phase 2. So on the filleting part, I think given how many lines and where they are located, it would be beneficial for us to actually go to the view tab of that fusion and display mode, change it to wireframe. So here it would be easier to actually select those edges and select one of these lines and hit fillet, and now I can add more lines to this selection set. So I'm being careful in selecting only the corners, the inside edges, and I should have selected more than 15, 16 total edges in here. Okay, so we are taking care of the vertical edges first, and then we'll come back. Actually, while we are doing that, maybe on the other side I can take care of these round edges too. It's on the other side. We've got 3 of those taken care of. All right, so that would be 2 millimeter fillet, and so the outside edge has been taken care of. Inside we have the vertical edges there. Now one more time I will add these 3 edges, so this time it's easier. So that's my second level fillet with 2 millimeter. Okay, now these two sequential fillets, it is important that we do it in this sequence. All right, that's our phase 2. Let's call this phase 2 completed and move on to the next challenge. It says we'd have to fix these 3 holes on the lower level and apply. Okay, so fix these 3 holes and apply 800 Newton load to each of these. Okay, so the continuous edge, so where we would find the continuous circle, that side we would fix it, and the broken edge will have application of 800 Newton on each. And material, it says plain carbon steel. We have dealt it last week, should not be problem. So let's switch over to a FEM workbench and start with the container. Should have a solver in it, and then we'd add a material. I'm going with 1C22, right? And this material has yield strength of 230 MPa and ultimate tensile strength of 400 MPa. All right, and then I add constraints. So this is going to be fixed boundary conditions, and here, so we talked about like having this continuous edge, so that phase will just add this. So this is our fixed phase, and this will have the loads. So we are applying 800 Newton load. Okay, so it should be vertical, and I'm gonna go ahead and unclick that add and select this one of the vertical edges and direction. All right, so let's see if this is the correct direction. So load direction is towards the hole. All right, so the other way, reverse direction. All right, so we added that. It would be 800 Newton, and I do that 2 more times. All right, those are our support and loading condition. And now I want to add a mesh. I'm going with Gmesh. First degree worked for me in the past, so I'll go with that one and give it a second. And it was done pretty fairly quickly without any warning. All right, it's time to solve this model in FEM, and writing the INP file comes first and then run calculix. Okay, let's see how long it takes. Fairly quickly. All right, so we have the results here, and before going to the result, I'm gonna hide this object and go to the CCX results. So that's how I have been looking at things. All right, that's a good angle. Go to displacement. We have very small amount of displacement, and somehow the displacement is not coming here. I know why. So the last force, I did not add 800 Newton. Okay, updated that and go ahead and rerun the solver. It was even quicker this time. And now let's go to CCX results. Now it has kind of same looking deformation. Still the deformation is very small, 4 micrometer, and we can scale it up to see actually how it would deform. So because this edge is discontinuous, it is moving the whole thing. Actually make it 200. See if that makes it easier to watch. So you can see, so it is depressing here, and also on this edge it is depressing just a little bit here too. So that's a good indication of how this object will deform under the stress. And let's take a look at how much stress it's creating. It's creating 38 MPa, which is way below than the allowable stress on this. The allowable stress is the yield strength, which is for the 240 MPa. So it is like way below than the capacity of the material, but this displacement is very insignificant. Now if you are using this in a machine where deformation is a big deal, but if it is something to hang on the wall, say you're fixing these 3 points on a wall and then hooking something up to just to hang things on it, I don't think deformation is big deal. On that case it would be the stress, so you would look at the stress. But places where deformation is important, say a ball bearing, deformation is really important. So things like that. So these are the two parameters actually normally people look into from FEM analysis, and there are like plenty more results that can be drawn, plenty more conclusions that can be done from FEM analysis. Anyway, that's all for this challenge. I'm gonna go back and try another way to see if I can build this model with changing this parameter in here. Okay, go to the data tab, polar number to 3, right? We got that. Now we were thinking we would update this repeating unit. Okay, and first thing is to actually, okay, I remember the parameters pretty well. So this radius is going to be 22 divided by 2, right? And I want a line that comes from here to there, from here to there, and I want to make this construction geometry and make these two tangential, right? Okay, what it did is kind of set up an area for the circular cylindrical hole. Okay, cool. How about we go in that wall and fix that too, right? So we'll have to make this construction geometry. This one stays there, which is good for us. And let's say 11 is the radius, and we are making just like this. Ooh, that was surprisingly easy. That was cool. I think just changing these two sketches would also work. Now all you have to do is like bring in a tube with outer radius of 11 and inner radius of 9, no, 8, and height of 15, and that's it. That is our phase 2. And then I just go ahead and make this one object, and that's it, folks. So even the phase 2 is simpler. All we had to do is change those array. I was a little skeptical on the limit of this connect object, that I thought it would mess up. One side becomes bigger than the other, but this is much better. So don't do what I did in the second part between, like when I was transitioning from phase 1 to phase 2. Do this instead. Just change the repeating unit and add a cylinder to it. I mean, I think both of these methods are equally effective in this case, transitioning from phase 1 to phase 2, but now you have an alternative in there too. Anyway, I hope you enjoyed this process of making this model in phase 1 transitioning to phase 2 in 2 different ways, and also the FEM analysis, and we know now what to look into FEM analysis and then what we get out of it. If you have any question, comment, or suggestion, please leave them below in the comment section. And thank you for watching. I'll see you in one of my next videos.